Alright, so this is how we do a practice problem where we have multiple objects, but we still want to use energy. Okay, and so for instance, in our problem here, we do have a disk that's mounted at the center, and it's going to be rotating, but not going anywhere. And I have a mass that's not rotating, but it is moving somewhere. So I have two objects, but each of them is only doing one part. Okay, so what we're going to do is, for instance, the mass 1, the rotating disk, I believe, is only going to have the rotating part, so it doesn't have this part. And the block is only moving linear, so it's only going to have this part, so it's not going to have that. But if I have multiple objects, what you end up with is you end up with talking about K2, the kinetic energy when the block reaches point 2, as being a pretty big thing. Okay? So, for instance, we're going to have block 1, so 1/2 m1v squared plus 1/2 I1 omega squared. So that's the kinetic energy of object 1 plus 1/2 m2v2 v squared plus 1/2 I2 omega squared. Okay, so we're going to take, and that just made that equation huge, huh? We're going to go ahead and take that kinetic energy, and it's going to be a combination of both kinetic energies of the two blocks. Much the same as when I do potential, it would be the potential energy of this block and the potential energy of this disk and the potential energy of that block. All right, we're going to cross some stuff out. So our block is not rotating, so that whole thing goes away. Also, our disk is not moving linearly, so that goes away. But you'll notice now that this one is going to have M1 in it, and this one is having M2. And so that my masses don't cancel out. But I do have a relationship between this omega and this V. So you'll note that this mass is moving at the same speed as this string, and this string is moving at the same speed as a point out there. So the velocity of this mass is equal to omega times the radius of my object. And this radius can change, so for instance, maybe I attach my string to an inner radius, and so it would just be that inner radius here to link the two. All right, there is your hint for the practice problem. The next video will be the example problem.